Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week from the Naked Scientists with me, Diana O'Carroll. This week we'll be exploring the psychedelia of copper.
Hello, my name is Vivian. I'm calling from Adelaide in South Australia. And my question is, why is copper the metal, copper in colour, yet when in solution with copper sulphate it's blue and copper carbonate it's coloured, and when you do a flame test it's actually green?
So how is it that one metal is so different in colours from others to start with? And what makes its compounds so much more exciting to the eye?
Hello, I'm Dr. Peter Wathers, and I'm a teaching fellow in the Department of Chemistry at Cambridge University. Now, metals in general reflect all of the light energy that comes onto them, but copper doesn't reflect all of them. It actually absorbs part of the spectrum. It absorbs the bluey part of the light and maybe some of the green light, but reflects all the coppery-coloured light, which comes back into our eye. So that's what happens with the metal. Now, in compounds, copper sulphate, the blue colour, is due to the light energy being used to promote or excite electrons that are in the atom of the copper when it's combined with other things such as the sulphate or carbonate ions and so on. So in solution, what you actually have, in the same way that when you dissolve salt in water, you end up with sodium ions and chloride ions, not bound together any longer as they are in the crystal, but surrounded by waters. Well, the water interacts with the copper ion. The colour that you see there isn't really copper sulphate any longer. It's copper ions surrounded by lots of water. Copper carbonate, the solid, doesn't have the same water there, and this is usually sort of a greenish colour. Incidentally, the copper sulphate, the crystals itself are blue, but that's because they also have water trapped into their crystals. But if you heat them up and drive out the water, they actually go white and colourless. So it's the waters there that are interacting with the copper ions. Finally, the flame test. Why does the element test produce a green flame? Well, this again is energy being used to excite the electrons in the atoms or ions. And then when this energy is returned, is given out again as the electrons fall back down to their low energy levels, it gives out only part of the spectrum, but it gives out pure green light.
The different electron configurations in copper leads to a more exciting selection of colours. When light, an electromagnetic wave, hits the copper atoms, it creates an electric current and the light is re-emitted. Copper atoms are special in that they have a reduced reflectivity at the blue end of the spectrum, producing reddish-gold colours. With each new copper compound, the electron distribution is reconfigured and new colours are produced. Away from the dazzling colours now, why not get some shut-eye to explore this next question?
Hi, my name is Paula Ovi. I'm from Johannesburg in South Africa. My question is about dreams. I was wondering why it's so difficult for us to remember our dreams when we wake up in the morning.
And take a deep breath for this question.
Hello, my name is Jason Flakes and I'm calling from Annandale, Virginia. My question is how is it possible for a bornine flat-headed frog to have no lungs and breathe through its skin?
So if you know why we forget dreams immediately after waking, or how a frog survives without lungs, then get in touch by emailing questionoftheweek@thenakedscientist.com or join the discussions on our brilliant and shiny forum at thenakedscientist.com/forum.
Question of the Week is part of the Naked Scientists podcast and supported by the EPSRC, the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.